to the first session of Big Mountain Data and Dev this morning. I would like to introduce to you Facundo Giuliani, who's a software engineer and full stack developer. He is from Buenos Aires, Argentina, and he has 13 plus years of experience in software development. He is a full stack web developer and Git Kraken ambassador. Facundo is a lead developer at multitracks.com, a music and tech company in Austin, Texas, and he is also an open source contributor. It's great to have you with us today, Facundo. I'll turn it over to you.
Thank you. Thank you very much. And thank you for the opportunity. So today we will talk about the Jamstack. We are going a little bit back to the roots of web development and web design. Well, we will talk about this new approach that is used to create new web pages and web applications. So yes, my name is Facundo Giuliani. I'm from Buenos Aires, Argentina. I'm a software engineer, lead web developer at multitracks.com. I'm an Auth0 ambassador, which is Auth0 is a platform for security and identity, and Git Kraken ambassador. Git Kraken is a graphic UI for to handle Git and to use Git. The talk is not related to these two platforms, but if you want to talk about them, we can do it through my different channels, which are my webpage, fgiuliani.com, my Twitter handle, Facundo Zurdo, and my GitHub account is fgiuliani. So, as I said, we are going back to the roots, so we have to travel a long time ago in a galaxy far, far away. This will be the only Star Wars reference that I will do during the talk. But yeah, we are going to the 90s, to England. Well, not to Switzerland, because Tim Berners-Lee was a British scientist working in Switzerland, and he created what today we know as a web page. It was an HTML document. It is still alive. If you want to go to the URL that is at the bottom, you can see the page live. It was a plain document with text and hyperlinks to other documents, not magic there. But well, that was the first approach to what we know today as a web page and a website. But the human beings always want more and more, and this was not enough to what we needed at that moment. So a group of people started to think about adding styling to these pages and colors and how to make a custom page. So what we wanted at that moment was to create pages like this one, for instance, this beautiful page. But yeah, being able to add images, colors, different fonts, different stuff. So at that moment, CSS was deployed to do that. But CSS was not enough. And what we started to need or to think about was about having interactions or movement in our pages, because we wanted to create products like this. I mean, like Homer's web page with different interactions, and depending on the user browsing, adding some behavior. But well, this is a joke, but this page, for instance, which is still alive, you can go to spacejam.com, the website for the Space Jam movie. And what was deployed at that moment was JavaScript, and a scripting language used for small interactions in the web pages. It was not like super complex at that moment for complex things. We had other languages like Java, for instance, but they were used to create desktop applications, not websites. But well, we had HTML documents with CSS styling and JavaScript scripting that added interaction, but still all the pages were the same. They looked the same for any user. I mean, if a user requested a web page at that moment, the web server always returned the same files as they were stored in the web server. So that's what we call nowadays static web page. It's a web page that is delivered to the user's browser exactly as stored. So yeah, I mean, if I were in I was in Argentina and I requested the web page, I was going to see the same web page as a person in Australia, for instance. And that's the concept of static web page, a static asset or a page that doesn't change and it's delivered to the user's browser as it is. But okay, that was cool at that moment. But what if we want to display information depending on the user that is logged in or the user that is using our web page? So that's where the concept of dynamic web page appeared, which is a web page where some of the content is generated dynamically when needed. What this means is that we have a browser, a user browsing a page, and the browser sends an HTTP request to our web server. The web server will use some static resources as CSS, HTML, and JavaScript, as we mentioned before, and some other dynamic information like algorithm or programs or databases where we store information. And with all that data, generate an HTML document and return the HTML document to the browser. So what we are returning is a static HTML or a plain HTML document that was generated dynamically by request of the user. So it didn't exist before as it is, as we are returning it. So to create these documents or this dynamic way of creating HTML documents, we have nowadays different languages, different programming languages that are known as server-side languages. For instance, Java at that moment was used to create desktop applications, but nowadays it's used for desktop applications and web applications or web pages. We have Python, PHP, Node.js, depending on what we wanted to do. We have different tools and different programming languages that we can use. But again, these languages were used by the web server to generate HTML documents that we return to the user. So at that time, we were able to create a site like eBay, because depending on the user interactions, the search, for instance, or the services or product that the user wanted to purchase in the site, we needed to generate a new HTML document at that moment. But sorry, that is what we know as server-side rendering. It's an HTML content generated by the web server. And why I mention by the web server, because with the years, new tools and new architectures and new, let's say, languages or frameworks appeared. And that's the example, for instance, as AJAX, for instance. AJAX is a group of technologies that we can use to generate HTML content dynamically from in the client side, I mean in the user browser. So AJAX is executed by JavaScript, which at this moment is getting more complicated or more complex or having more features than what it had when it was created. And JavaScript makes a request to the web server to get some information, like calling an API, for instance, and with the information received, generate dynamically HTML content inside an HTML document that we are seeing. So in this case, we are not requesting an entire HTML document to the web server. or the web server generating a complete HTML document, but we are requesting information that we will use in the browser to generate HTML content. So that's when JavaScript started to have more features and more tools, and new frameworks started to appear to play with the user interface or the web components that were displayed in the browser. That's the case of jQuery, for instance, or Ember or Backbone. But with all these tools and the way JavaScript was being used, new tools started to appear, and new ways of thinking the web pages started to appear. So the interaction that we started to have with the web pages was getting more complex, or I don't know, we had more operations that we were able to do. And that's where a new concept appeared. We stopped thinking about web pages and we started to think about web applications, like the ones that we have and we had in the desktop. Now we started to be able to interact with the browser and with the web servers as if we were using a desktop application. So we had different types of features and resources that were available for us to do operations or interact in a richer way. And that's where, for instance, Angular appeared, or React or Vue.js. They are front-end frameworks that are used and were used to offer more interaction to the user. So this new concept appeared, and what we thought at that moment, or what was thought at that moment, is what if instead of always that we need a new document or new information from the web server, we request a complete new HTML document? What if instead of doing that, we request an initial HTML document to the web server, and all the changes in the HTML and the operations are done inside that HTML document, only using JavaScript and calling APIs and generating the dynamic content inside the HTML document that we loaded at first? So that's where this new concept appeared, which is single page application. It's a web application that interacts with the user, dynamically rewriting the current web page with new data from the server. We are not leaving the HTML document, or we are not leaving the web page to a new one whenever we want to do an operation or interact with the application. And this can be done with a new approach of rendering, which is client-side rendering. The HTML content that is rendered in our page, it is rendered directly in the browser using JavaScript. So again, you see, we are generating the dynamic content in the browser with our device. I mean, if we are browsing the page in a computer or a mobile phone, for instance, the device is the responsible of generating the new markup or the new HTML content in the page. So with these different approaches that we discuss, we can identify some pros and cons for each one. For instance, this last one that we mentioned, client-side rendering, some pros that we can mention is that we have richer interactions, because whenever we want to do anything, we don't have to go to the web server to request a complete HTML document. We have a faster rendering after the initial page load. When we loaded the HTML, the initial HTML document, all the CSS file, all the JavaScript files, and all the initial framework, initialization is done, the render will be faster because we don't have to load a new HTML document whenever we are doing something. We just need to to dynamically create the HTML content that we need at that moment. So by this same case is that the server load will be lower because we don't need a web server generating HTML content all the time. We will use our browser to do that. And on the other hand, we will have reusable user interface components because we are not loading a complete HTML document, but we are reusing some components that we created in HTML, and we are only rendering what we need at that moment. But some cons that we have in client-side rendering are that this initial page load that we mentioned before will be slower because until we don't have all the JavaScript loaded and all the scripts executed in our page, we won't be able to interact or even display our application. The way React or Vue or Angular work, this framework work, is having this initial loading in the page and rendering the HTML of our application. We have to wait for that until we can start using our application. On the other hand, there's this concept that I didn't mention before, which is SEO. It means search engine optimization. This is a group of techniques and algorithms that search engines like Google use for to track and to analyze and to inspect all the web pages, and depending on these techniques or the result of this analysis is that we get better results in the search engines. So your web application will appear in the first results of the search, depending on how you optimized this way of rendering the information or the content of your web application, and some HTML tags that we can add to our pages. So the robots that analyze the pages from Google or for any search engine like Bing, for instance, they will do it better or easier if you have all the content available when you request the page. And that is the problem. Client-side rendering generates the HTML dynamically in the client side. So if a robot from Google requests our application, we won't have the HTML generated and not all the content will be available to be analyzed. Nowadays, Google or Bing support JavaScript rendering, but it's not as optimal as the server-side rendering. And on the other hand, another cons that we have with client-side rendering is that we depend on many external libraries. If we created our page or our site using React or Angular or Vue, we depend on them and the way they work for our application to work properly. The server-side rendering, some pros that we can mention are that this initial page load that we mentioned before is faster because we don't have to wait for JavaScript to load our page and to display content in our page. We will have better SEO and social media optimization, the same as I mentioned before. They are more secure because the code of our application will live in the server and not in the client in JavaScript, which is visible for any user. And we will have a lower user device load because the HTML content is generated in the server and not in the browser. But some cons are that we will have busier web servers. So if we have a lot of requests all at the same time from different users from different parts of the world, maybe we will overload our web server and our application will start working slower, for instance, or we will have problems maybe generating the HTML content that is requested. By this same cause is that the overall page rendering will be slowed because, again, if we have a lot of people at the same time requesting the page, our web servers will be overloaded, and we have to handle that in a certain way. Maybe we have to add additional web servers, and to do that, we have to deploy a load balancer, like to divide the amount of users that are using our page at that time. On the other hand, one of the cons is that whenever we change the route in our application or we request an operation, we have to do a full page reload. And it's not so cool seeing that the page is always reloaded whenever we do anything. And the last thing that we will mention is that even though that the page is viewable sooner, because you don't have to wait for JavaScript to display the page, it will be not interactive until JavaScript is loaded. So for instance, if we have links or buttons in our web page or web application that depend on JavaScript to work, maybe the user can click the buttons and they won't do anything because JavaScript didn't load. So that's something that we have to evaluate. If we want to wait until the JavaScript is ready to display the button, or if we want to first display the page and the buttons, and after that, wait for JavaScript to load. But there was this group of people a couple of years ago that thought about, I mean, they remembered the static web pages and they said, okay, why don't we go one step forward or backward in this case, because static pages were older. And they wanted the benefits and the advantages of static websites to be back in our current web application. So what they really wanted is to create beautiful pages like this, or like this one. Well, you got the point. I mean, this is not beautiful, sorry for the creator, but what they wanted is to create pages getting advantage of the benefits that static web pages offer us. So for instance, static web pages are fast and cheap because they are static assets that are living in a server. And the only thing that the web server does is deliver this content to the user. I mean, we don't have any operation there. We don't have any evaluation. We don't have any HTML rendering there. It's just grabbing a static asset that is living in a disk, a hard disk in the web server, and deliver that to the user. So that is faster than having to generate HTML content dynamically by request. That is cheaper because we don't have any kind of platform living in the web server to generate HTML content. That is easier to maintain because you can even handle the files manually in the web server. That is more secure because you don't have any logic being executed when you request a page. You just receive a static asset. And it's easier to scale because just adding more capacity to the hard disk or the servers, you will be able to store more information and more files. And it's stable because as you don't have any operation happening there, it's just delivering the content. So they thought about all these benefits, and they went one step forward, and they thought about this concept, the Jamstack concept. What is Jamstack? It's a new way of building websites and apps that deliver better performance, higher security, lower cost of scaling, and better developer experience. Well, this is like a formal definition. It doesn't explain anything, but let's dive into the concept and what it means, what it really means. Jam comes from the J from JavaScript, the A from APIs, and the M from markup. And we have some principles that Jamstack follow to create web applications. For instance, we should try to generate cacheable static assets at build time whenever is possible. So when we execute our website or we build our website, we will need to try to generate static assets and static HTML pages whenever is possible. I mean, the maximum amount we can, the maximum amount of static assets that we can generate, the better, because we have less dynamic content that we have to generate on the fly, and well, all the benefits that we mentioned before. These static assets, we should deploy them to CDNs. CDNs are content delivery network. They are networks of web servers that are optimized to store static assets and static content. And they are networks because we have different servers that are called nodes, and they are in different geographic points of the planet, but they replicate the same content. I mean, your application or the files that compose your application will live in different nodes or servers in different parts of the world. They will be the same file. So depending on where the user lives, the request will travel to the closest node at that moment. So for instance, I live in Argentina and I have a node of the CDN in Brazil. My request will travel to Brazil and bring the files from Brazil's node instead of going, I don't know, to the United States to bring the files of my application, which makes the request faster and our application faster. And the last principle is that we should use client-side JavaScript to call third-party APIs and serverless functions for dynamic interactions and data. So as we won't have any web server generating server-side rendering and pages, we will have static pages that will use JavaScript to call APIs that can be third-party or not. I mean, they can be APIs that we create, or serverless functions if we don't want to, I don't know, maintain a web server or a platform like with Internet Information Server or anything. And the JavaScript will be the one that will generate the dynamic content for our pages and will generate these interactions and data, bringing information from the APIs and not from a server that is server-side rendering our pages. So we will have this build system, which can be a continuous integration server or continuous deliver server. And it will be the one that will execute the build of our project, generate the static assets, and they will be automatically deployed to the CDN. And from the CDN, these static assets using JavaScript will call the APIs that we need to get data and to generate the interactions that we want for our site. This build system, we have different alternatives that we can use, and these builds have to be what we know as atomic build. What it means is that we will execute it and generate all the static assets that we need for our website. If we have any problem while generating the files or building our project, we will stop the build there and we won't deploy anything. So we will only deploy the assets and the files that compound our application if everything was correct at that moment. This is done to keep the web page working correctly and not delivering partial parts of our application, maybe generating inconsistencies that will make our web application not work correct. But as I said, we have different tools and different alternatives of services that we can use to help us to create applications following the Jamstack approach. One of these tools is the static site generator, which is a software that produces and deploys a static website using data sources and templates. This means that we have a project where we have templates, which are HTML files maybe, or markdown files using the markdown format. And these files we will use with data and content that we will grab from APIs or from different sources like databases or content management system, a concept that we will talk about later. But grabbing information from these different sources and using templates that we already have, we will execute the static site generator, this tool, to generate static assets that will compose our website. Which is cool is that these tools also deploy the static assets that we generate to a CDN, for instance, or a web server to live there. I mean, to have the release of our web application. We have different options of static site generators depending on the programming language that we want to use for the templates or for the generation of static assets using the data sources. For instance, if you like React, the React framework for JavaScript, you have static site generators like Next.js or Gatsby, for instance. If you use Vue.js, you have Next. If you use Go programming language, you can use Hugo. And there are a lot of static site generators, and there are a lot of alternatives to select depending on the programming language that you want to use. But one other concept that I mentioned before are the content management systems. Those are applications or set of related programs that are used to create and manage digital content. If we have a content team that we want to write or to create content, and we have entities that we handle in a certain way, we can use a content management system to make it easier for them to generate the content that will conform our web application. In this case, we have content management systems that are well known by many users and developers, which are WordPress, Joomla, or Drupal. And these CMSs offer a backend part and a front-end part or a presentation layer. Let's take WordPress as an example. We have the admin panel in WordPress where we can create the content that we will use in our website, our blog, for instance, or our articles that we will expose. And the application that we create in the backend of WordPress is presented using this front-end layer, also created by WordPress. And well, using PHP, we generate the HTML content that we want to display in our website. This has a problem, or not a problem, but this is one approach. But with the Jamstack, what we wanted to do is to generate static assets. And to do that, we have to separate the backend part from the presentation layer in the CMSs. So a new concept appeared, the headless CMSs, which are CMSs where the content repository is separated or decoupled from the presentation layer. So let's talk about the same example. Let's suppose that we have WordPress platform to create the content and to handle the entities that we use in our website, but we don't have the opinionated presentation layer that we use to generate the HTML content for our pages or to expose the content to the users. We only have the backend part that can be stored as markdown files, for instance, or a database that can be accessed by APIs exposing JSON objects that we can use for instance, using JavaScript in our site to dynamically generate the content, or at build time to generate our static assets with the static site generator. There are lots and lots of headless CMSs, and they depend on how you want to store the information and how you want to expose the information, and the different tiers that you can have I mean, you will have 3 tiers if you want to use, depending on the size of your application or system, and they start to charge you depending on how big your site gets. We have, for instance, headless CMSs that store the information in markdown files that are after that saved in the same repository where your application lives. Let's say that you are saving or the code of your application in a GitHub repository. Well, we have headless CMSs that can store the information in markdown files inside this GitHub repository, or we have other headless CMSs that store the information in databases, and they expose this information using APIs, for instance. You can choose and evaluate the best tool depending on what you need for your application or what fits better for your application. And the last service or tool that we will talk about is the build, deployment, and hosting services. These services help us to automate all the deployment and building process of our application and not having to do manual tasks. For instance, as I mentioned before, let's say that all the code of your application lives inside a GitHub repository. So whenever code of the application is changed, or whenever content of the headless CMS or content that is living in your repository is changed, I don't know, by a commit in the repository or a pull request created in the repository, these services what offer are that they build the site, they build the application using the static site generator. If everything is correct and we create the static assets, they deploy the static assets into CDNs that they already maintain. I mean, they are maintaining. They offer the group of service, executing the static site generator or the build of your application from the repository, normally in GitHub, or you have different types of services to control the versions of your software. They generate the assets that compose your application. They deploy them automatically to the CDNs, and they host your application and offer them to all the users in the world. We have different services for that. Vercel, Netflix, GitHub Pages. Some of them are free. Some of them have free tiers, and they start charging you depending on the size of your application. But I think all of them, they mainly offer the same features, which are building your website, deploying the files, and hosting your website. And well, these are tools that we can use again to automate the workflow of creation and the workflow of edit of our web application. You don't have to manually execute the static site generator, create the static assets, deploy them manually to the CDNs, or having your own server that you have to manage. They are all done. These tasks are all done by the server, these services. And we have many other API services that we can use and are third party. For instance, we have serverless apps that we can create with AWS Lambda functions or Azure functions. If we want to create forms in our app, we have services like FormSpree, Typeform, or Netlify Form. If we want a database that exposes an API, we have FaunaDB, for instance. If we want to add authentication to our application, we don't have to worry about creating a security platform or authentication platform. We can use Auth0, for instance, or Firebase authentication. The point here is that we should focus on creating our application and do what we do best. I mean, getting the best of our product and creating a great product, but focusing on what we really need to do and not having to reinvent the wheel. Because we have other companies and we have other platforms that offer these services to us. And let's say that they focus on that. I mean, in the same way we focus on our applications, they focus on offering the best service. For instance, Auth0. They have security experts and a lot of engineers that are working every day to have an authentication platform that they try to make it the best authentication platform, to offer that to us, so we can use a security platform that we know it's good, and there's a big chance that it is better than any authentication platform that we can create, because we don't focus on security. We don't work on security. Maybe we do, but in this case, if we want to create a page or a website that is not related to authentication, let's say that we don't focus on that. So we have to leave the best people to do what they best do. So this is the idea of using third-party APIs. The same for search engines or e-commerce platform, Shopify, Snapcart. They are e-commerce platforms that are already working and that are created by people that focus on that product to offer the best product. So let's try to use it. Well, the same if you want to leave, have a part in your web application to leave comments, or if you want to handle images and videos in your website. You have Cloudinary to that. Don't reinvent the wheel. Spend the time on improving your product, improving your web application. And well, with all these services and alternatives that we have, we are going to the finish of the presentation, but we will mention some pros and problems that we have with the Jamstack. The pros are very similar to what we have with static web pages, as we mentioned before. We have better performance, more security. They are easier to scale. We will have better SEO because the HTML content is already generated. It's a static asset, so it's the easiest way for a search engine to analyze our page, because the static assets already live. We don't have to wait or to dynamically generate any kind of content. We will have better caching for that. The servers that we have to handle are cheaper because they are only storing static assets. The CDN is optimized to serve static assets, and we don't have to worry about any processing or any platform of dynamic generation. And what is also good is that as we are using new tools and new approaches, we will have a better developer experience, which we are developers, so we want that. But there are some problems that the Jamstack has, and we have different codes to evaluate. I was talking before that we have to leave the best to do the best, but okay, the companies and the services, they don't work for free. They offer free tiers, and some of them offer free options of their services, but we will have different codes to evaluate. For instance, the Headless CMSs or the services that we want to use to deploy our site, or the third-party APIs that we want to use. We want to evaluate this cost and trying to make our site as cheapest as we can. And on the other hand, evaluate which options fit the best for our application. the same, we will have external dependencies because we will work using services from third-party APIs, and we depend on them. I mentioned the atomic build time, that we wait until all the static assets are generating to deploy our web application. The problem with this is that as our application gets bigger and bigger, we will have more assets to generate and the build time will increase. So we have to evaluate that and trying to improve that. There are some services that are working on them. Well, some companies that are working on this to offer a better service with partial deploys or partial builds. But again, this is something that we have to consider at the moment of creating our web application. And the last problem that we will mention is the content editors that create the content for our website. They have to use these headless CMSs. We have to evaluate which is the best or which is the most friendly headless CMS for our content editors, because they will have to work with this. And sometimes we have the developer point of view and we see something that maybe we understand, but we have to think following the content editor point of view and trying to see that the tools that we are using are easy for them to use. So again, the Jamstack, it's a new approach. Maybe it's not the only solution for all the problems in the world, but it's a good approach to use tools and concepts that we already have and that were deployed many years ago to improve the way our web applications work and to offer a better experience to the user and to the developer, creating fast, more secure, cheaper, and easier to scale web applications. I encourage you to give Jamstack a chance, try to, I don't know, evaluate a web application that you already have and how would you refactor it using the Jamstack, or maybe creating a new project following this approach. And I don't know, maybe you will get a better side or better performance than you will have if you used one of our past approaches of creating web applications. But again, it's a good approach, and I encourage you to try it and to give it a chance. So thank you very much for the opportunity again. Those are my social networks. If you want to talk to me, I'm available. Thank you for your time.
Thank you, Facundo. We do have one question that's coming through Slido. It's from Lauren. Is there a Jamstack tutorial you recommend for getting started?
Well, there's a lot of information in the web. I will share in Slack in the channel after the presentation, but we have an official page of Jamstack, which is jamstack.org, where it was created by the group of people that developed this concept or named the concept. And you have different ideas, tutorials. You have a list of static site generators that you can evaluate, or headless CMSs. Everything is inside the same portal, the jamstack.org. And you have, for instance, local meetups if you want to attend to talks to learn, and different tutorials and links to material to make it easier to follow this approach, because it's kind of a generic concept and you can use different tools depending on the programming language that you want to use, or how you want to develop your application. But again, in this portal, for instance, you have different options or links with different tutorials following and using different tools.
Great. It doesn't look like we have any other questions at the moment. If you have one, please drop it into Slido or into the Slack channel.
Sorry, one more thing. I think there's a feedback form that you can load. It will be super cool for me or for the conference if you can fill that feedback form to know, well, what if you like the presentation, if there's something to improve or something to change. on, well, that will be great.
All right, last call for questions for Facundo. All right, I'm not seeing any more, Facundo.
Okay. I hope it's because everything was clear and not because it's a mess and nobody understood anything. Cool.
It was great. Thank you very much for your presentation.
Thank you for the opportunity, and we'll see you later.
Okay, bye-bye.
Bye.